Hi everyone, this is Kim Delatorre going through my Module 5 on my paper circuits. Previously, my students had done a STEM challenge on building a sturdy bridge to see how much it could hold. The new STEM challenge that I'm combining the paper circuits with is to take their previous challenge and improve it by making it light up with the paper circuits. My prior knowledge of any kind of circuits is just playing with snap circuits in an after-school program. I didn't really have much knowledge of them, so I really got to play with them during the planning. So obviously we go through the engineering design process. This is just an old bridge that was left behind that I got to work with since most students took theirs home with them. So I first start asking, how can I complete a closed circuit and make an LED light up? So the students wouldn't know much about circuits either, so just kind of testing with the ones that I learned from the book and seeing how they can make it work. So really knowing the positives and the negatives and the way that circuits function. And the second question is, how can I add the LEDs to my bridge to improve its design? So we first start with Imagine, and so I went through several practice ones. I used the simple circuit first, and then I tried the parallel circuit and kind of had fun with that. And finally, I tried the blinking slide switch circuit or template to make the little light bulb light as I slid my finger across. So I had a lot of fun just playing with them and learning how they work. So I was really drawn to the blinking slide switch because my first thought was, well, maybe I could make it look like a car was moving across and different lights would come on. So my first design, I was creating the circuit around, and I was kind of imitating the way that the one in the book was going. So I had my paper ready and I was trying to make it slide that way, and it wasn't working. So then I had to come up with a new plan, and I went back to the one that was just a continuous one. So I was looking at the parallel circuit, and this was going to be more like a continuous light on a bridge. So when I created it, I ended up making 2 lanes with the parallel circuit, and I had multiple LEDs along both pathways. So when you first get on, it lights it up, and you have the blue and white lights there, and then the red and yellow lights on this side. So it's kind of like different lights with different flows of traffic. So to improve, I would go back and try to do the blinking slide switch. I was really just curious about that one, and I wanted to get it to work. So I think I would just continue playing with it, or maybe try other variations of the circuits from the book. And I was kind of curious with the advanced stickers. One had effects, sensors, and just like a microcontroller. So there was other things that I wanted to try. Or maybe even adding like the binder clips to the ends of the batteries, so it's just one long flowing continuous light. When I look at the STEM specification chart, I was pleasantly surprised to see that it marked yes on the majority of them. It does present a real problem with engineering lights on a bridge. Students relate to this. I stated that in the lesson plan, where they use electricity every day, and they've probably been through either a tunnel or seen lights outside at nighttime when there's a whole series of lampposts lighting up at once. It allows for a lot of creativity since there are multiple design solutions, especially since the students already had different design solutions for their bridges. I marked the number 4 as a somewhat yes, because although they are applying science and learning how energy transfers from the battery to the LED lights, the math is not much there unless they're calculating how much copper tape they would use, or how many LED lights they want to use in their circuit. It does go through the engineering design process. It's completely student-centered since they're the ones discovering how the LEDs work, how the circuits can function properly, and how they want to make their design. They will obviously develop their model and change it up. They're using the technology of the circuits and electricity to work. The students are always paired in groups when they're working on different STEM challenges in my classroom. And they will have to continue testing until they get it to work. So whether they're putting the different sensors, LEDs backwards, they would have to retest to see how it works. And finally, in the lesson plan, I also included how they would each present their design and do kind of a gallery walk to see other students' designs as they go in class. Thank you so much for listening. I hope to get some good feedback.